Hi everyone, I hope you're doing well. So this is 4.4, Properties of Logarithms. And we mentioned several properties last time. In particular, we mentioned the fact that when you have an exponential function, right, say a to the x, right, where a is the base, that the inverse of that function is the log function, right? So log base a of x, right? And I know we did this last time, but I just want to emphasize that when you take any function and you compose it with its inverse, right? You take f of f inverse of x, you just get back x. And if I take the inverse function first of the original function f, you also just get back x, right? So what does that mean in terms of the log function? Well, if you take f, that's going to be a to the x, but you're taking f of the inverse function. So this is a to the power inverse of f inverse, right? And if that's the exponent, then the exponent is log base a of x, right? And that's just going to be 1. That's going to be x. It's going to be x. As long as x is greater than 0, because remember, you can't take the log of 0 or negative numbers, right? So, yep, that's an important one. And the other one, if you take the log base a of f of x, you're just taking the log base a of a to the x. Right? And that's also just x. But that's going to be true for any x. Positive, negative, doesn't matter, right? So that's a G here. So, yep, this is also an important property as well. It's one that's going to come up again and again. Right? And maybe I should even just remind you what a logarithm is, right? It's so if I have a to the m equals n, that means the same thing as m is log base a of n. Right? So make sure you understand that. Right. And we also talked about the change of base formula. The change of base formula here, right, is also very useful, especially when you want to use your calculator to calculate, say log base 7 of, 15 or something, right? Then you can use the change of base formula, or your calculator could probably do it directly, but not all calculators can. So depending on your calculator, you might have to use the change of base formula for yours. Okay, so now we can talk about 3 more properties, and they go by the product rule, the quotient rule, and the power rule. And so I know that they're kind of small here, so I'm going to write them down again down here. So let's start with the product rule. So this tells you what to do when you take the logarithm, any base, of a product, m times n. Okay. Well, the product rule says that you add the 2 logarithms. You take the log of m plus the log of n. Right? You don't multiply them here. It's not log m times log n. So why not? Why the plus instead of the times? So if you remember from your intermediate algebra days, we gave you this rule here, that if you take the a to the power m plus n, then you multiply a to the m times a to the n. Well, remember what a logarithm is. It's an exponent. So you don't multiply m times n here, you add them. So you're adding the exponents, which means you're adding the logarithms here, right? You're not multiplying. Okay, so that's the product rule. Maybe a quick example where we actually use this. Suppose you want to take, let's say, the natural log of 3x. Well, according to the product rule, we can write this as the log of 3 plus the log of x. Right? So we're gonna do a lot more examples like this, but this is just an easy one to start. All right, so the next rule is called the quotient rule. And that says what you have when you have a logarithm, log base a, of, let's say, m divided by n. Well, if you remember the rule for exponents, I'm using the wrong color here. Right? If you take a to the m minus n, that's a to the m divided by a to the n. So likewise, here for logarithms, and boy, that looks like a 1 here. It's supposed to be an L. Log base a of m over n is just going to be the difference, right? Log base a of m minus log base a of n. Okay. So just a quick example. Suppose I have, let's do log base 10, so I don't have to write the 10, of, w over h. Well, according to the quotient rule, this is just going to be the log of w minus the log of h. Right? Not hard. Just takes getting used to, right? Because you don't want to do, well, okay, so I'll warn you about this later. But the one thing you don't want to do here, of course, is to take, right, the log of m divided by the log of n. In particular, because we know what this is. This is actually log base n of m, right? This is the change of base property. So don't get those mixed up, right? There are two different rules here, right? Okay. And then the last rule for this section, anyway, is the power rule, which says what to do when you have log base a of n to a power p. The rule says you can bring the p in front and multiply p times log base a of n. Okay. And this rule essentially just comes from the reverse of this rule. Suppose I have a to the m to the power p. Well, that's just a to the m times p, right? So p times m is p times log of n, right? Because the log is the exponent. Remember, the logarithm is the exponent. Okay. Yep. So a nice example of this, well, suppose we have, let's do log base 5 of y squared. So how else can we write log base 5 of y squared? Well, so my a is 5 here, right? My n is y, and my p is 2. So if p is 2, that 2 can come in front and multiply log base 5 of y. Right? And then that's it. So, right, so I hope that helps. By the way, another way you could do this example here, squeeze it in down here, you can also do this the following way, right? You can say log base 5 of, instead of y squared is y times y, right? And now that should remind you of the log of m times n. Now here, m is y and n is y. They don't have to be different, right? It's like the 3 and the n, the 3 and the x here were different, right? M times n, 3 times x. But here, m and n can be the same thing. They're both y. And if we do that, then this becomes the log of y, base 5 of y, plus log base 5 of y, right? That's by the product rule up here. That's a plus sign, right? Okay, well, what's 1 log y plus 1 log y? You get 2 log y. Sorry, that's an L, not a 1. So 2 log base 5 of y. Right. Yep, same thing that you got by using the power rule. And in fact, this was a lot faster than having to go through all this using the product rule. Right? But they give you the same answer either way. Okay, now I feel like I should warn you about something because there's a very common mistake people make here. So this is a warning. Right. Right. Suppose I have, let's just say, log base 10 of x plus 7. So how can we rewrite this? Well, you might be tempted to say that this is the log of x plus the log of 7. That would be nice, but it's wrong. Don't do this. Okay? I know that's very tempting, but it's not going to work. Right? And here's why. Look at this thing on the right. Right? Log x plus log y. That should remind you of log m plus log n, right? But what was the log of n plus the log of n? That's right here, right? That's on the right side of the product rule. So you can rewrite this going backwards. You can write it as the log of m times n, or in this case, you can write this as the log of, right? Well, let me write it here, right? The log of m times n. But that would mean that, right, if I wanted to write log x plus log of 7, well, according to this, that would be the log of x times 7. Right? So this is true, actually. But now you can see the issue here. 7 times x is not 7 plus x, right? Adding and multiplying are definitely not the same thing. Right? So that's why this is wrong. That's why you cannot do this, right? And I understand the temptation, right? I understand why you would do this. After all, if I had, let's say 4x times 2x minus 3, well, by now you know how to expand this out, right? You would do 8x squared minus 12x. You just do that instinctively because you're multiplying 4x times 2x minus 3, right? So you distribute the 4x. So then why don't I distribute the log? Well, because it's not a number, right? It's not an expression like 4x. Right? Furthermore, you're not multiplying, right? When you write log of x plus 7, right? The way to read this is the log of x plus 7, right? So if you read this, in your mind, log times x plus 7, well, then you're probably going to make this mistake up here quite a bit, right? So don't even think that. This is not log times anything, right? It's a function, right? By now you're used to this. You don't say f times x, right? You say f of x. So likewise, this is log of x plus 7. If you don't say f times x, don't say log times x plus 7, because that's not what it is, right? It's a function, right? It's like f of x, right? Okay, so I hope that helps, right? And of course, the same thing is true when you're subtracting, right? If you take, let's take the natural log of, r minus 2, right? So hopefully you know by now that this is not log r minus log 2. You cannot do that, right? For the same reason that you can't do it up here when you're adding, you cannot do it when you're subtracting, right? Because what this is, the log of r minus 2 is actually the log of r divided by 2, and, right, subtracting and dividing are not the same thing. So yes, just make sure you understand that this is definitely wrong. You cannot do that. Okay. Yeah, so again, this will take getting used to, because remember, these are functions. You cannot distribute like you can with, numbers and terms and things like that, right? Okay. Okay, so do another example. We want to write as a sum and difference of logs to the power 1. So the expression is log of x to the 4 divided by 10y cubed. Sorry, that almost looks like log here, right? This is a 0, right? So 10y cubed, right? So what's the idea here? Well, right, so this should remind you of the quotient rule. This is my m, this is my n. So using the quotient rule, I can write this as log, this is base 10 now, right, of m, which is x to the 4, minus the log of n, which is 10, y cubed. Okay, so that's the first step, right? That's just by using the quotient rule. Quotient rule. Now what? Well, now you might think, okay, I can bring this 4 in front, right? Because that's the power rule here. And yeah, you can do that. Why do we do that, right? So this is going to be 4 times log of x. And that's by the power rule, right? Now you might think, well, then I should also bring this 3 in front. No, you can't do that. Not yet, right? Here's the issue, right? This is a product here, right? This is m times n. So we have to use the product rule first here, right? This 3 only goes to the y, right? If the 3 were on the outside here, right? If it were 10y all to the power 3, of course, then you can bring the 3 in front. But this 3 here, right, this exponent of 3 here only goes to the y, so we cannot bring it in front of both. So instead, we're going to rewrite this as log of m plus the log of n. Okay? All right. Now this is also wrong. Why is this wrong? Because you're subtracting the whole thing here, right? We need parentheses or brackets around this. Right? So even though this is a plus, we're going to distribute the negative sign, and that's going to give us 4 log x minus the log of 10 minus the log of y cubed. Okay? Now, if you're thinking, well, wait a minute, why is it a minus when this is times here? That's the product rule. This should be a plus. Well, it is a plus, but it's on the inside of the parentheses, and you have to distribute, right? They're both minus now. Okay? So yeah, be careful of that, right? What else? So 4 log x, that's as good as it gets there. Log 10, if you remember log 10, that's just 1. And now we have the log, the log of y cubed. Right? Now we can use the power rule here. Right? We can take this 3 in front and write this as 3 log y. Okay? And that's it. Right? Now it's a sum and difference. Well, it's a difference of logs to the power 1. You could put the negative 1 anywhere you want, right? And I would actually put that in front. But it doesn't matter. This just maybe makes it look a little bit nicer here. Like I say, I'm not going to be picky about the order, as long as the order doesn't matter. Okay, next example. We want to essentially do the same thing here. We want to expand as a sum and difference of logs to the power 1, but now it's log of x squared minus 5x minus 36. So I hope you remember my warning. This is a difference, right? You cannot write it as the log of x squared minus the log of 5x minus the log of 36. Right? There's no rule that says to do that. Right? So remember, when you have something like log of x minus 5, there's no way to simplify that. You just leave that alone, right? Whatever it is, it's not the log of x minus the log of 5. Okay? So yeah, keep that in mind because it can get you into trouble, right? So what do we do then? How can we write this as, a sum and difference of logs when it's the log of a difference? Well, this is where you have to remember your factoring skills. right? We can write it as a product. X squared minus 5x minus 36. I hope you know how to do that. Right? You're just looking for two numbers whose product is negative 36 and whose sum is negative 5. Right? So it's not 1 and negative 36. It's not 2 and negative 18. It's not 3 and negative 12. It's going to be 4 and negative 9. Right? So 4 minus 9 is negative 5. 4 times negative 9 is negative 36. Okay. So how does that help? Well, right, that allows us to write this as, well, let me just copy it down first, right? This is the original question, but now we can write this as the log of x plus 4, times x minus 9. All right. So now it is the log of a product, right? It's the log of m times n. And so we use the product rule. We're just going to write this as the log of m being x plus 4, right, plus the log of n is x minus 9. And that's it, right? So, yep, so again, forget all this. The actual answer here is log of x plus 4 plus the log of x minus 9. X minus 9. Right. And again, you have to get that because you have to know how to factor. And that's something we presume that you're used to doing by now, I hope. Okay, another example. Now we want to write as a single logarithm, right? So now notice we have the sum and difference of these logarithms. They're all base 2, right? But they all have different arguments. They all have different m's and n's, if you like. So how do we write this as a single logarithm, right? In other words, our goal is to write this as log base 2 of what? Right? What goes in the parentheses here? Right? So that's our goal. And to do this, well, you're using the same properties as before, but now you're just going the other way, right? In other words, you're taking this sum on the right here and writing it as the log of a product, right? You're taking this difference and writing it as the log of the quotient. You're taking any number in front and you're putting it into the exponent, right? So you're just going right to left instead of what we've been doing is going left to right. But it's the same rule. You just have to get used to it, forwards and backwards. Okay, so let's see. What do we do here, right? So first thing I would notice is that this is, right, the log of m plus the log of n. And we know the rule for that is the log of, well, I'll write it here again, log of m times n. Right? So we can combine these as log base 2 of m times n. N being x squared plus 4, right? So yeah, that's using the product rule, but backwards, right? Now we still have minus log base 2 of x plus 2. Okay. So what can we do with all of this? Well, because it's a minus sign, we're going to use the quotient rule, the one right here in the middle, right? So that's going to be the log of the quotient. Right? So we can write this as log base 2 of m, right? So this is my m here, and this is my n. So m divided by n, right? In this case, it's going to be m is 3x times x squared plus 4 divided by n is just x plus 2. And now it's a single logarithm, right? And in fact, we're done. You might ask, well, why didn't I multiply out the 3x here? No reason. You can if you want. So, all right, so let's write this as log base 2 of 3x cubed plus 12x, all divided by x plus 2. Right? So notice that nothing factors here, nothing, right, you can't simplify any further. So either way is fine. And right, so there's our answer. So now we can complete this. And I'll write it this way, even though, actually, I would prefer you leave it factored. 3x times x squared plus 4 in the numerator, divided by x plus 2 in the denominator, right? So that's what you're taking the log of. Now it's a single logarithm. Oh, let's try that again. Just put a box around my final answer. All right, so that's how to write this as a single logarithm. Okay, another one, single logarithm, right? So this is base e here, right? Remember, natural log is base e. In fact, if you want to write it as, log base e, that's fine with me. It turns out not to be necessary in this problem, but in problems where you maybe want to solve for x, then that's maybe a good idea. So this is the log of what, right? Well, this is a difference, so I'm going to use, right, the difference rule. Well, it's the quotient rule, right? So this is the log of m divided by n. So my m in this case is the x squared. My n is the x squared minus 4x. So this should be written as the natural log of x squared divided by x squared minus 4x. Okay? And that can go in here. However, we can simplify this, right? We can simplify this. Well, I hope you don't cancel the x squares. You know you can't do that, right? Because you're not multiplying here. But here's what you can do. You can write this as the natural log of x times x in the numerator. And notice here you can factor out an x. This is x times x minus 4. X times x minus 4. All in the parentheses. Now, because you're just multiplying, right? Because you're just multiplying here and here, now you can cancel one of the factors of x, right? But you can't do it here. That would be bad. It would be wrong, right? So this is really just the log of x over x minus 4 after you simplify. Okay. Right. So I hope that helps. Yes, and in some cases you do have to simplify, like in this case, but not always. Not in the previous example. There's nothing to simplify here. At least I hope you see that. Right? And so I think that's it for the properties of logarithms. Again, it's just getting used to these three rules, both backwards and forwards, right? So both ways. You can always go left to right or right to left, depending on what type of problem it is. If you want to combine them into a single logarithm, then you're going right to left, right? If you want to split them up as a sum and difference of logarithms, like we did here, then you're going left to right. So